Hello guys, welcome back to DSA playlist by 2am Coder. We are covering sorting technique in this playlist, and till now we have covered selection sorting, bubble sort. And in this video we are going to talk about quick sort, which is the one of the hardest sorting technique, but it is efficient than whatever we have spoke till now. So without further ado, let's get started. Now before jumping to the code, let's try to understand how quicksort actually works. So basically quicksort uses 3 steps to sort any array. So let's quickly write those 3 steps that we will going to use while implementing the algorithm. So step 1 will be find the pivot. So what is pivot? That we will see. First I'll write the steps, then we will try to understand each step one by one. Step 2, divide and conquer. You might be knowing what is divide and conquer, right? We have to divide the array and we have to execute something. So we have to keep dividing the array and we try to execute same thing again and again, and that will be the step 3. Sort each division So basically quicksort uses these 3 steps to sort the array. First one is find the pivot. So what is pivot? Pivot is the position in the array in which all the elements which are lesser than the pivot element will come at the left side of the pivot position, and whatever the elements which are greater than the pivot will come at the right side of pivot. So initially we have to consider any one element as pivot. So in our case we will consider the last element as the pivot element. You can consider any element as pivot, first element as pivot, but in my case and most of the time everyone will consider the last element as the pivot element. As I said, pivot is the element on which all the elements which are lesser than the pivot element should come at the left side, and all the elements which are greater than the pivot should come at the right side. So this is the pivot element, which is 5. Let's write it here. Okay, so what and all elements are there which are lesser than 5? We will keep them in the left side of 5. So here you can say it's 2. So 2 will come here. And how many numbers are there which are lesser than 5? Okay, there is only one element which is lesser than 5. Okay, that will come in the left side, and remaining all the elements which are greater than 5 should come at the right side. So here you can see, and then 9 will come here. We will copy paste this, put it here. 12 is also greater than 5. Copy paste this, put it here. 7 is also greater than 5. Copy paste, put it here. 6 is also greater than 5. Okay, we have considered 12 2 times, so let's make it 15. Twice, and 15 is also greater than 5, so it will come at the last. And this arrangement, how it is happening, that we will see in the algorithm. Okay, so but the main point here is initially we consider the last point, that is 6, as the pivot point, but the actual position of 5 is index number 1. So here if I write the index value, so this is the index value. Now we know what is the actual position of 5. It is 1. Actual pivot value is 1. Initially we considered 6 as the pivot value, but after some algorithm we found that the actual value of pivot is 1, because the correct position of 5 is index number 1. So basically pivot is nothing but the element where all the value which are less than that pivot value should be in the left side, and whatever the value which are greater than the pivot value should be in the right side. So if we do this arrangement, pivot value will come at its correct position. So basically now it's in correct position. So now we found the pivot, which is 1. Pivot is not the value, pivot is the index number. So basically 1 is the pivot value here. Now Now divide and conquer. This is the second step. So in divide and conquer, we divide the array in two different parts and we try to execute same thing in both the parts. So here in this case we have two array now. If we divide it, now you can say this particular part, the index 1, which is a pivot point, now it is its correct position, so it is sorted. Now we have to apply quick sort again in this array and in this array. Basically we need to divide array in two equal parts and we need to apply same logic again. So that is nothing but step number 3, which is sort each division recursively. We have to follow recursive approach where same method will call itself with different index starting and ending value. Okay, so here you can see this is only one element in the array. So anyway, it's already sorted, because if there is only one element in the array, we can say that is itself a sorted array. So we can remove this. Now we need to apply quicksort again in this particular array. So what I will do, I'll move this pivot from here, because we are considering last element as the pivot element. I'll put it here. Okay, now I have pivot as 15. I want to put this 15 in its correct position with some sort of algorithm that we will see, but it should be in its correct position. So here you can see 15 is the greatest number here and it is actually at its correct position. So we don't need to further find the pivot value here because this is at its correct position. So now again, when we find the actual pivot value, which is again here, it will be 6 because it's at correct position. We need to follow the divide and conquer and then sort the array with recursively. So once we find the actual pivot value, which is 6 here, we need to divide the array and we need to sort it, and we need to use the recursive approach to sort those division. So we need to divide this. Now this will be our left side array, and as you can see right side there is nothing, so we will only focus on the left side and rest of the part is sorted. You can see now here the starting is 2, end value is 5, and as you can see we always consider pivot as end point. So here the pivot is 5, so we need to put 6 at its correct position. So let's copy this. We will put it here. Now how many items are there which are lesser than 6? So there are no item which are lesser than 6, and rest of the item which are greater than 6 should become at right side. Let's copy them and put correct position. 12 should come here, 7 should come here. Let's write the index value here as well. So as you can see now 6 is in its correct position and the actual pivot value is 2 here. Okay, now again once we find the pivot value, we need to further divide the array in two equal parts. So there is no left array and there is right array with 3 different elements, which is this, and again we need to apply the same logic. So again what I'll do, I'll move the pivot value from here to here, because now we have to assume that the pivot value is 5, which is the last index in this particular array. Now again we need to put this 7 in its correct position. So we will copy this, put it here, and how many items are there which are lesser than 7? So there is no item which are lesser than 7 and all the elements are greater than 7 actually. We will just put it at its right position, which is in the right side. So now we know this is the actual position of pivot. Now quickly we will write the index value here. Okay, so actual pivot value is 3. So 7 is the pivot value we had, and now it is at its correct position. So we found the actual pivot, which is 3. Again we need to divide the array and we will follow the same recursive approach. Left side there is no array and right side we have array with 2 elements. We will apply same logic here as well. Let's move the pivot value from here to here, and you can see index 0 value, index 1 value, index 2 value, index 3 value. Now these elements are sorted. Also the last index value, which is 6, this is also at its correct position. So these indexes are sorted now. Now we need to sort the remaining index, which is 4 and 5. Now again you can see pivot value is 12 and it is at its correct position only, so we don't need to further move this from here to somewhere else because this is in its correct position. So actual pivot value is 5 only, and again we need to divide this array. So left side there is only one element, and when there is only one element we are not going to apply anything because it's already sorted. So we will just remove this. So as you can see, this 2, we will bring this 2 here, bring this 5 here, bring this 6 here, we'll bring this 15 here. So now you can see 2, 5, 6, 7, 9, 12, 15. This array is sorted. So guys, let's try to implement this particular logic here itself, and for that what I'll do, I'll just keep this sorted array here. Let's place it here. Okay, so I have kept the output here. So this is the final sorted array with the index value. So we will follow this when we are trying to find the pivot value. We will see, we will match this if we are in track or not. Now to basically find the actual pivot value, first we need to consider any element as the pivot element. So we will consider the last element as the pivot element, pivot, which is PV, and also we will need two more pointer value, which is I and J. So basically pivot will always be the last position, and we are considering J as always the starting position, and I will be always starting -1. So I'll quickly write it here. Initially I will be S-1, J will be S, and pivot will be ending value, not value but the index and index. So this is the initial setup. So this we have to make sure we follow this. You know, all the value which are lesser than pivot should be at the left side. So whatever value we will see which are lesser than pivot, we will try to swap it with I index, and we will see how we will do that. Okay, so the main logic here is we need to find the actual position of pivot. So this is bit tricky part, and for that I'll write the logic here. So we need to check for J value till pivot -1. So we are not going to check the pivot value with J because we will keep moving the J value to the next index until pivot -1. We will check the J value with the pivot value. So there is no point of making J value as equal to the pivot value. Okay, so it should be always less than pivot, and we will keep increasing the J value with every iteration. This is the initial setup we have. Okay, so I'll also write the initial setup here. I is equals to S-1, J is equals to S, and pivot will be E. So in our case, initially I value is -1, J value is 0, and pivot value is 6. And we will keep going until pivot -1. If we find any element, so this is the main part, if you find any element in J index which is lesser than the pivot value, so if you find any case which will satisfy this, that means the J value is lesser than the pivot value, what you will do, we will increment the value of I, and swap the value of I with value of J. So what we did, we are assuming pivot as end point, we are making J as starting value, and we are making I as starting -1. Now we need to check the J value until pivot -1, that means end -1, or you can write here end only, but anyway we are considering pivot as end, so that's why I have written pivot here. We will keep moving the J value, and we will keep checking J value with the pivot value. If anything is lesser than pivot value, we will increment the value of I, and we will swap the value of I with value of J. And this way, whatever the value are there which are lesser than the pivot value will come at the left side. Check if value of J is less than pivot. No, it is not. We will increment the value of J. Move it. Now you can see the value of J is less than value of pivot. We will increment the value of I, and we will swap the value of I with value of J. So 2 will come here and 9 will come here. Now again, after swapping, we will increment the value of j. Value of j is not less than pivot value. We will increment again. This is not less than pivot value. This is also not less than pivot value, so we will increment the value of j. So this is also not less than the pivot value. Now once we come here, we will come out of the loop. Now still you can see 5 is not at its position, where the actual position of 5 is. So here you can see 2 is here and all the elements are actually greater than 5. So the actual position of 5 is nothing but index 1. So that's what here we have in the answer also. If we swap index I plus 1 value with pivot value, we will have pivot at its correct position. That means at index 1. Swap array of I plus 1. That means index 1 array of pivot. If we swap them, 9 will come here, 5 will come here. After that, what is the actual value of pivot? We can say whatever we have as I plus 1 is the actual value of pivot. That means index value 1. Now we need to divide the array where the first part is the left part and second part is the right side part, and we will follow the same logic again using recursive approach. So this will return the pivot value. Return pivot. Okay, let's consider this is one method. Basically this is returning pivot value, so return type is int find pivot. What else we need as a parameter? We will need array, we will need a starting point, we need end point, and from here what we are doing, we are finding the actual pivot value. So in quick sort, finding the pivot value is the only logic you should understand, and rest all is very easy. Let's keep it here, and we will also write one method called quick sort. Now here also we need array, we need starting value, we need end value, and why we need it we will see just now. Now as you can see, we found the pivot value. This we will find the pivot value using this find pivot method. We will pass the same array as the starting index and end as the as the end index. Increase the size. So from this method we will call find pivot. Now we find the pivot, actual pivot value, which is 1. Now we need to sort the array. Now we need to divide them into equal part from pivot minus 1 and pivot plus 1, and we need to apply same logic again in those two array. We will simply call this quick sort method. So this is nothing but a recursion where method call itself. We will pass array. We are not going to change the array object, but we will change the start and end point. So since it is the left part, start will remain the same, but end value will change from e to pivot minus 1. We will recursively sort the left part, and we also need to sort the right part as well. For that, again we will call the same method array, but here the starting point will be pivot plus 1 and end will be e only. So you can see we are changing the end value and starting value, and we are always increasing the starting value and decreasing the end value. That means we will call this method again and again with updated starting and end value, and till what point we need to call this method? Until start is less than end. Otherwise it will be keep on going and it will go to infinite loop. So we need to restrict them. So we will call this recursion until we have starting value as less than end value. Now we will call this again and again, and we will get the pivot value. We will divide the array into equal part with this approach. This is one array where start is nothing but 0 and pivot minus 1 is also 0. Quick sort array, and this is one array where pivot plus 1 will become your start point. This is the start point, and end point is nothing but the same end point. Okay, so when we call this method again, it will go to find pivot method. Again, it will follow the same logic where last index as the pivot point, and also the starting value will be 2 and I will be starting -1, which is 1. Again, it will follow the same process and it will give you the next pivot value here somewhere, and you will get the next pivot point in this array. You will divide this array further and again follow the same logic, and you will find the new pivot value in those sub-array. So you will keep dividing until you see when the s is less than e, and as soon as s will become equal to the e, that means there is only one element present, then it will just break the loop. So guys, I hope you have understood the logic, and we will try to code this in IDE. So let's jump into IDE. Let's quickly create one class for quicksort. So okay guys, I have taken this array and we will simply print this without sorting. So as you can see, now it is not sorted. We have to implement those method here. So we need to find the pivot, right, initially. So I'll write static because we are calling from static method, and we need to return pivot value as int find pivot. We will take argument array, starting index, end index. Now to find the pivot, we know that we are considering pivot as the endpoint always initially, and we need two pointers. One is I and one is j, where I will be starting -1 and j will be starting index as well. And we need to check the value of j always with the pivot value, and we will keep moving the j value. Okay, so for that, while loop where j will always be less than pivot value, and we will keep moving the j value to the next index. And whenever we find any value in the j index which is lesser than the pivot value, what we will do, we have to increment the value of I, and we will swap array value I with value of j. For that, let me create one method, swap array. So this will be start index, where you can say first, second, okay. Now this method is completed. Now we will simply call this method from here. We'll pass the array, we will pass those two indexes. So we need to swap I and j value. We will swap it. So with this condition, what will happen, we will have all the value which is lesser than the pivot value at the left side, and we need to place the value of pivot at its correct position, which is nothing but the I+1 value. So again, after this while loop, when the while loop ends, that means now we went from here to here. We have done one iteration. Then we need to put this pivot value to its correct position. So for that, we need to swap the array I+1 and the pivot. After this, pivot will become I+1 and we will return the pivot value. Okay, so this is the actual pivot value. Actual pivot index, which is I+1. So this is the main method of quicksort. Now there is one method we need to make as quicksort, where we will take array as argument, starting index, end index. We will get the find pivot method. Once we have the pivot value, we need to sort this particular part and this particular part. by dividing this. For that we will use recursive approach. Left side starting point will not change. We will have the updated endpoint, which is nothing but pivot minus 1. And for the right side, start point will change to pivot plus 1 and endpoint will remain same. And we have to keep doing until we have s value as less than e. Once it will be equal to each other, that means there is only one element present. That's the point when s will become equal to the I. That means when there is only one element, s will become equal to the I, right? So we don't need to sort them because it's already sorted. And that is it. We will find the actual pivot value. We will sort it again with updated start and end point for left side and right side. Left side value. This is right side. And let's call this method from here. Quick sort array. Starting will be always 0 and will be array dot length minus 1. Let's run this again. Now you can see this array is sorted. So I hope you have understood the main concept. So here main concept is nothing but is finding the pivot value. You need to divide array into equal part and then follow the same thing again with recursive approach. So that's it from this video, guys. I hope you like what you saw. If you like, share with your friends, like the video, leave your comments. I'll see you in the next video. Till then, bye and take care.